Hello dear students, today we'll solve the latest paper, that is February-March 2024 variant 2, because in February-March 2024 there is only one paper, so that is variant 2. Let's start the paper. Question number 1, uh, speed time graph for first 5 minutes of this bus journey. You can see that this is a speed time graph. From this graph we can find the acceleration gradient is as acceleration, and the distance is equal to the area under the graph. So what is the question? Describe the motion between, okay, so 0.9 to 2.9. So you can see from here 0.9 to 2.9. So you can see that between this part the speed is constant. Very easy. So you will write constant speed. Okay, next part, from 2.9 minutes to 3.5 minutes. So 2.9 to 3.5. So this is, yeah, 2.9, 3.5. So you can see that acceleration is constant. So constant deceleration, you can write it, because the speed is decreasing. When the speed is decreasing, the acceleration is negative or deceleration. There is a, so constant line, so you can write constant or uniform deceleration. Deceleration. Okay, next one is 3.5 to 4.5. So you can see that at this line, no speed, only the time. So the object is at rest at zero speed. So object is at rest. So 3 marks. Another bus travel at the speed of 8.9 meters per second. The brake apply a constant force and the bus stop at a distance. The bus have a mass of this. Calculate the kinetic energy of the bus before the brakes applied. So what we have? We have mass, that is 18,000 kg. We have speed, that is 8.9 meters per second. And we have distance in this equation, that is 23 meters. So what we will do? We will find the kinetic energy. For kinetic energy, no need to write the distance. So 2 marks. So kinetic energy is equal to 1 by 2 times mass times square of velocity. So mass is 18,000. Speed is 8.9 meters per second. After using calculator, you will get 7.5 times 10 power 7.1 times 10 power 5. There is no unit, so unit is very important, joule. You can write in the kilojoule as well. Calculate the force applied on this bus. So how will you calculate the force? We know that kinetic energy is equal to the work done. So we have kinetic energy, that is 7.1 times 10 power 5 joules, because the joule is the unit of work and kinetic energy as well. We have the distance, that was, what was that, 23 meters. So you find the force. In this case, kinetic energy is equal to the work done by the engine. So you will find the force. Very easy. Work done is equal to force times distance, or force is equal to work done or kinetic energy over distance. Putting the values, 7.1 times 10 power 5 divided by 23. So after solve, you will get 31 kilo Newton or 31,000 Newton. Define impulse. 1 mark. So very easy. You can just write when a force act on any object for very short time, or just for 1 mark you can write impulse is equal to force times time. Time should be very small for impulse. B part, figure 2.1 show a rocket and its exhaust engine. So rocket is moving upward because of the downward action. So here's the Newton third law, which is equal to the change in momentum. So the exhaust gases are emitted from the rocket with the velocity of 1400 meters per second at the rate of 2800 kilograms per second. So we have the speed, that is 1400, and we have at the rate of, so we have mass per second. So what we'll find, show that the force exerted on the rocket by the exhaust gases is, we have to prove it. So state the equation you can use. So you have to write the equation as well. So what is the equation for it? We know that impulse is equal to change in momentum, and change in momentum is equal to mass time velocity. So let's state the equation first. So equation, impulse is equal to force time short time, that is equal to change in momentum. And change in momentum, we know that change in momentum is equal to mass over velocity, mass time velocity. So when we calculate the force, so we know that we need to calculate the force. It is in the Newton. So Newton will be equal to mass velocity over change in time. So you can see that mass over time, kilogram per second. This is a value of 2800. The speed is given, that is 1400, 1400. Just put the values and you will get the answer. So mass over time is 2800 times 1400. That should be equal to, nearly equal to 3900 kilo Newton. Calculate the maximum mass that the force can lift from ground. Ignore the resistance. Force W is equal to mg. That is, we know that weight which is applying by the rocket, that is equal to force, that is equal to mg. So we need to calculate the maximum mass. So mass will be equal to weight or force over g. What is the force? That is given, we found it, 39 kilo Newton. So we can write 39,000 Newton because we have to remove it, and divide by g, value of g is 9.8 obviously. So here I'm using the equation, force that is equal to W, that is equal to 3900 kilo. Kilo means 1000 Newton. Let me confirm. Yeah. So the value of g is 9.8 meters per second square because this is the acceleration due to free fall. So when you solve it, you will get the mass of the rock. That will be equal to uh, 4 times 10 power 5 kg. There is no unit, so unit of the mass is kilogram. Okay, question number 3. A car has a weight of 13,000 Newton. Is supported by 4 tires. The area of each tire is this. Calculate the pressure on it, the pressure of the on the road of the car due to the weight of the car. So we know that pressure is equal to force over area. But in this case, force is equal to weight of the car. That is equal to 13,000 Newton. But we need to calculate the pressure for 4 tires, but this is the area of one tire. So total area is equal to 4 times 0.016 square of meter. By putting the values, the weight, and 4 times 0.016 meters square, so you will get the answer. What is that? 200 kilopascals. 200,000, so you can write 200 kilo, and the unit of the pressure is Pascal, or you can write the unit of the pressure is Newton per meter square because area is given in the meter. Explain in terms of particles why air pressure in the tire increase when the car traveling along a road. 4 marks, so you have to write the 4 points. So there is when the car travel on the road. So the tire is touched with the road. It's mean there are friction. There is friction between the tires and the road. So we will start from here. When the car move, there is friction between road and tires. First point, due to friction, we know that temperature is increased. Friction cause the temperature increase. So temperature is increase. Okay. When the temperature is increased, or we can write temperature of the air inside the tire is increased. Temperature is increased inside the tire. Okay. When the air particles increase, they move faster. Obviously, they move faster. We can write uh, the air particles move faster. When the air particle move faster, they will collide. The collision rate increase. The collision rate increase. In many questions, they ask the same question, different situation. So you can write these 4 points. Why the if what is the effect of the temperature on the air particle? So you can write these 4 points. Collision rate increase. So it's mean the pressure increase. Don't need to write this pressure increase. Obviously, they are given that the pressure is increased. So pressure increase. Next question. A gas cylinder contain a helium gas at a pressure. So this is the pressure. A volume. This is the volume of the compressed gas is released into the balloon. A balloon contains 0.5 cubic meter. We need to find the volume of the gas cylinder and we will divide that volume with this and then we will get the answer because we need to calculate the number of the balloon. So this is the volume of balloon. We need to calculate the volume too. So we know that P1 V1 is equal to P2 V2. So we need to calculate V2. So that will be equal to P1 V1 over P2. Okay. By putting the values, what is P1? 2 times 10 power 6. V1 is 0.026 divided by P1 was 1 times 10 power 5. Okay. By calculating the volume, we will get the answer that is V2. V2 will be equal to 0.52 cubic meter. So what we'll do, we'll find the number of the balloons. So total volume is 0.52. The volume of each balloon is 0.0015. So the number of balloons will be equal to total volume divided by the volume of the one balloon 0.015. So by using calculator we'll get 34. So question number 4 defines specific heat capacity. So heat capacity is basically energy absorbed like product of mass times specific heat capacity times change in temperature. So you can use this equation to define specific heat capacity. So energy absorbed by unit mass per unit temperature change. So this is a complete definition of specific heat capacity. Why? because when we make the subject, heat capacity will be equal to E over per unit mass per unit change in temperature. Okay, B part is a volume of 0.0024 cubic meter of oil. This is a volume is heated for a pan for 7 minutes, so this is a time. The temperature of the oil increases from 20 degree to 180 degrees Celsius, so this is change in temperature. The density of the oil is given. The specific heat capacity is also given. Calculate the mass of the oil in the pan. So let's calculate the data. So first of all, we have a volume that is 0.0024 cubic meter. Second we have the time that is 7 times 60, that is 420 seconds. Okay, the change in temperature. How much temperature is changed? 180 minus 20 degrees, so that is 160 degree Celsius. And the density is given, that is 910 kg per cubic meter. And the last we have the specific heat capacity, 2000 joules per kg per degree Celsius. So we need to calculate the mass. So how to calculate the mass? First of all, what we need for the mass. Okay, so we know that according to this data, we have the density and we have the volume. So by using these two quantities, we can calculate the mass. So we know that density is equal to mass over volume. So mass will be equal to density times volume. Just putting the values, multiply them. 0.0024 cubic meter. So you will multiply and you will get 2.2. And there is no unit, so you will write the unit as well. Calculate the energy required to increase the temperature of the oil. So we need to calculate the energy. So as it is, I described the equation above. That is E is equal to mass times specific heat capacity times change in temperature. So mass we found it 2.2. Change in specific heat capacity is 2000 and change in temperature was 160 degrees Celsius. So when you multiply them, you will get 7 times 10 power 5 joules. This is the energy absorbed by the oil. Calculate the power required to energy transfer. Energy calculated in 5 in question. We just solved it. So what is power? Power basically is energy over time. So we used change in temperature. We use specific heat capacity. So the time is given. Let me finish this. Okay, the time is given, that is 420 seconds. The energy is given, that is 7 times 10 power 5. So very simple, power is equal to the rate of doing work or rate of energy transfer. It's the same formula in chapter number 8, I guess. So we have 7 times 10 power 5 divided by 420 seconds. You need to change the minutes into the seconds, so you will get 1700. There is no unit, so again units are very important. So 700 1700 watt. Question number 5, A1. Table 5.1 show application on regions of electromagnetic spectrum. So there are 7 spectrum. Complete a second column of the table with the region of electromagnetic radiation. Okay, so these are the radiation. Sometimes they will not give you the radiation. You need to memorize them in the order. This is very important. So these the uses are written. So we need to write the exact uh, electromagnetic region. So Bluetooth is a radio wave. Second one, optical fiber. Optical fiber we use infrared or visible light. So visible light is not given, so it's infrared. Security making, ultraviolet radiations, to slice the food, to kill the germs in the from the food. So we use gamma radiation. And the last one, wireless internet, microwaves, the wave which are coming from the satellites, or we use the microwaves and wireless internet as well. So state the approximate speed of the radio waves in the air. Whether it is a radio wave, all electromagnetic waves have the same speed, that is 3 times 10 power 8 meters per second. The speed is constant. So show two successive crests of wave after a plane of through the gap. So this is a diffraction. Draw three successive crests before it. So in the diffraction, the wavelength is not changed. So we need to calculate, or not calculate actually. We need to draw three lines. We should be the wavelength. Basically, this is the wavelength. So the distance should be equal between these three waves. How much? Equal to this. Yeah. So you will draw three lines. Figure 5.2 show much wider gap, a plane wave of the same wavelength. Okay, what they did, they increase this gap. And let me tell you one thing: to more diffraction, the gap between the two slits should be equal to the wavelength of the wavefronts. So in that case, the diffraction will be maximum. So it's mean when they increase the gap more than wavelength, so the diffraction will be decrease. So draw three successive crusts after wave passing through the gap like this, because the gap is too wide, so the wavelength will be decrease. Okay, figure 6.1 show a full-scale diagram of the object or image I produced by the converging lens, this lens and its position. So principal axes are not shown. Okay, the question is draw a single ray to locate the image of the center of the converging lens, a line that represent the LMO position. So very easy, and this is very important. So what you will do, first of all, you will join these two tips. So when I will join these two tips approximately, it's not accurate. So this is the position of the lens because this line is passing through the center of the lens. So I will draw the line and I will write L. So one mark for a ray, that is center, and the second mark for the lens, position of the lens. Determine the focal length of the lens by drawing the lens. So how to find the focal length of it? Let me erase this. Okay. Now you will draw the parallel line of the principal axis and till the lens, and from here you will join the tip of the image again. So this is the position where the reflected ray, this is the refracted ray crossing through the principal axis. So this is principal focus. What we need to calculate, the focal length. So focal length is the distance between the center of the lens and the principal focus. So this red light represent the focal length. You will use a ruler to calculate this length in centimeters. Okay, the object is moved 2 centimeters closer to the lens. State two changes. So when the object move 2 centimeters, so obviously if I draw the focal length on this side, because the focal length on each side is equal, so this is a principal focus as well. So when we move the object towards the lens 2 centimeters, what happens? The lens will be on the focal length, and when the object will be on the focal length, so the image will change. It is a real image will be imaginary virtual image, and image will be on this side, upright image will be formed and greater image will be formed. So what you will write, state two changes of the characteristic of the image change into virtual, image will be virtual, and image will be upright. And or you can say that Image will be on left side on the lens. So you can write any 2 points. Next question, draw the circuit symbol for the potential divider. What you will do, you will draw the resistance and you will mention the sliding contact on it. So this is the symbol of the potential divider. And this is the diagram of the potential divider. Two resistance and in the series, and we are taking the output from it. So calculate the output voltage of the R is value of R is 3 kilo ohms. So what we write? V output voltage divided by voltage of the resistance R is equal to output resistance divided by the resistance. Now putting the values, so we'll get voltage of R resistance will be equal to 3 times voltage of output, so that is 1.5 volt. Next question. The value of R is adjusted until the current is 1.7 milliamperes. So this is current, and this is the time we need to calculate the charge over it. So we know that Q is equal to I times T. Putting the values 1.7 times 10 power minus 3, that is milli, times time is 300 seconds. So we'll get the value of charge, that is 0.51, and unit of the charge is coulomb. Next question. Figure 8.1, a wire carrying a current, large current. So this is a card and this is a large current passing through it downward. Figure show a squared viewed from the above. So the cross represent the inward. On figure 8.2, draw the magnetic field lines indicating the direction of magnetic field and how the strength varies with the distance from the wire. On 8.2, you will draw, so this is the diagram of this card. So what you will do, you will use the right hand rule. What is the right hand rule? When you hold the wire with the right hand and thumb set in the direction of the current, so your curling fingers will indicate the direction of magnetic field. So when I set my hand in the direction of the current, the curling fingers is indicating the direction of clockwise direction, like this. So in the direction of clockwise, you can complete the circuit as well as it is. So uh, three concentric circle you draw it, and you can see that what you will explain. In this region, the magnetic field strength is weak because it is far from the source of magnetic field. And in this region, the magnetic field strength is strong. It will be strong. So you will write here. So how these magnetic field is changing. The current in the wire increase and the direction is reversed. So obviously the direction of reverse, so the magnetic field will be anti-clockwise. First it was clockwise. So now the magnetic field is anti-clockwise. And what is when we increase the current? Obviously, when we increase the current, the strength of magnetic field will increase. Strength of magnetic field is increased with current. Next question. Electricity is transmitted at high voltage. Explain why the high voltage increase the efficiency of transformer even in the thinner wire. The resistance is increased. Resistance is inversely proportional to the area. When the wire is thinner, the resistance increases. So what is the high voltage? High voltage causes, so I'm explaining the answer. So high voltage allow the low current at the same power. Thin wire have high resistance, so the current have greater effect of the efficiency of the high resistance. That's why we use high voltage to transmit the line from the power station to the city, home electricity. Next question. An experiment is directed alpha particles at very thin sheet of the gold foil. Most of alpha particles pass through thin foil in a straight line. State one conclusion about it. So you can see that if let's suppose there is gold foil and most of alpha particles pass straight through it. A few of them like slightly deflected and very few of them deflect back, but mostly they pass the gold foil. So it's mean their atom is weakened. There is more empty space in it. So what you will write? You will write most of atom is empty. Okay, next question. Some of alpha particles are deflected through the angle less than 90. A few of them deflected 180. I already explained. So state and explain two conclusions about the nuclei of atom of this observation. Next question. A source contains a radioactive isotope of strontium. The isotopes decay by emission beta particles. The half-life is 29 years. State the name change in the nucleus which occur when the beta particles is emitted. So when the beta particle is emitted, one neutron in the nucleus change into a proton and electron. That's why the mass number stays same, but the charge due to electron is increases. That is beta decay. Next is the initial mass of the isotopes is 25 microgram. Calculate the mass of strontium isotopes after 87 years. So what is this? This is the half-life. So one half-life is 29 years. So when we calculate the number of half-life, we need 87 divided by what is that 29 years, we get three half-lives. So after three half-life, there is equation as well. So remaining activity is always equal to the total mass is 25 divided by 2 power the number of half-life. Number of half-life is 3. So 25 divided by 8. So that is 3.125. But this is undecayed. The question is calculate the mass decayed in 87 years. So obviously the remaining 25 minus 3, that is 22, approximately 22 microgram, that is decayed mass. The next question is figure represent the position A to H. The moon as rotate it's around the earth. So this is the arrows represent the sunlight from right to left. So these are the stages of the moon. State the position of the moon where an observer on the earth see. So there is a quarter moon, there is a full moon. So you can see that where is the quarter moon, where is the full moon. So at position A and position E, there is a quarter moon. So the quarter moon is, you can write this position is A or you can write E. Both are correct. Where is the full moon? So full moon is always on the other side. So this is full moon. This diagram is given in chapter number 24 in your book. State the approximation time to the moon of the orbit around the earth. So we know that approximate time, actual time is 27.5 days, or you can write 1 month. The average distance of the earth is, so this is the distance which is given. Calculate the orbital speed. Actually this is the value of r, so we need to calculate the kilometer per hour, so no need to change kilometers to meters. So we know that time speed is equal to 2 pi r over t. So this is the orbital speed. So 2 times 3.14, this is the constant. R is given. I'm putting the value of r divided by. Now we write the time. We know that in 1 year, because Earth complete its rotation in 1 year around the sun. So there are 365 days, 365 2.2 exact days, 24 hours. and we need to calculate the value in hours, so that's it. We will calculate it, and the answer is 110,000 kilometers per hour, the value or the speed of the earth around the sun. The speed of the light in vacuum that is given, calculate the time taken for the light to reach from the sun, that is approximately 500 seconds, but we need to prove it. So we know that the time is equal to distance over speed. Yeah, so distance over speed. So the distance is given. What is that distance? In the previous question, 1.5 times 10 power 8. Uh, but in this case, we need to remove the kilo, so it will become 10 power 11. 10 power 8 plus 10 power 3 divided by v, that is 3 times 10 power 8 meters per second, and the speed is 500 seconds or 8.3 minutes. Question number 11. State the condition required the protostar to become a stable star. So we know that when the star is it stable, so it means there is a nuclear fusion reaction. So what is a nuclear fusion reaction? Fusion reaction, hydrogen changing to helium. So there is outward pressure due to heat, due to energy. So when the outward pressure is equal to inward force of gravity, so at this stage the star is stable. Define the Hubble constant. What is the Hubble constant is basically the Hubble constant is represented by h naught, which is equal to 1 over t, or that is equal to speed over distance. So you can write the ratio of speed. And what is this speed? The speed at which galaxy is moving away from the earth, at which galaxy is moving away from the earth. Okay, it is the ratio between the speed and the distance. And what is distance is? The observer distance. That's it. So by using this equation, you can define the Hubble constant. The current estimate for the Hubble constant is given. State the equation which give the an estimate age of universe. I already wrote it. So h naught or time is equal to 1 over h naught. Calculate the estimate age of the universe in the seconds. So we'll use the same equation and we will just put the value of h, that is 2.2 times 10 power minus 18 per second. So after calculating this value, you will get the answer, that is 4.5 times 10 power 17 seconds. You will get 5 marks. So hope you understood all the question. If you have any question, you can ask in the comments, and if you have any suggestion, you can give your comments. And if you need the online lesson, I will leave my email in the description. So have a nice day. Goodbye.